Tonight we have Matt Makens with us. He's a meteorologist from Colorado with 20 years of experience communicating information about weather trends and data. He runs Makens Weather, which provides seasonal and long-term outlooks. And some of his clients are Cattle Facts, which is well known by many of us here, as well as other industry groups in the United States and Australia. He is providing us with quarterly written reports, with seasonal outlooks, with Canadian maps, with breakouts by region and province. And those are available on the CanFax website if you're looking for that. And the most recent one was from mid-March. And so that's now available. And we're excited to have Matt with us over the coming year. And in 2021, he was named Best Local TV Weather Forecaster in Denver by a local media outlet. And so welcome, Matt, and I'll turn it over to you.
All right, thank you very much. You can see the monitor behind me, but I'll share my screen just so it's easier for you to follow along with the graphics. And we'll lay out everything that's going to be happening throughout the course of the year. So there comes your graphics at you. And basically what I really feel like we need to talk about is always the preparation and the risk management that comes along with weather and all of these concerns. So thank you for including me in this very important town hall. I take weather extremely seriously. I come from an agricultural background. My family still farms in the northern plains of the US, even though I'm based outside of Denver, close to Cattle Facts and NCBA. So my philosophy on the weather is to focus our efforts on minimizing that long-term impact to our operations, and we do that best with preparation. I believe weather is cyclical. I think we develop forecasts to be best are those forecasts that are rooted in the probability of occurrence, not what models say. They have to be based on probabilities, what's most likely to occur. What I'm going to discuss today is rooted in that philosophy of probability-based forecasts and outlooks. I'll make mentions of uncertainties as they arise in today's presentation. I think transparency is not necessarily common when it comes to weather communicators, so I'll show you where I'm transparent, and I think that goes hand in hand with any good weather presentation. So to begin, I put together a brief overview how the globe is doing, what the weather has been doing here recently and why it's been doing that. We'll see why the storm pattern was created, how long it can continue, the global vegetation, where did we benefit in those areas, where have we lost some good growth in other areas, as well as cattle areas. And then we'll focus on Canada's outlook for the rest of the year, and I'll also hint into early next year. So to begin, let's start with the sea surface temperatures. And what you see here on your screen is, this is a snapshot from a satellite. Areas of oceans are either warmer, the yellow shades, or colder, the blue shades, and that's colder than average. Areas of warm ocean cause humid, warm air to rise up, and that creates storm systems, and then they move downstream. So it's critical to know where those warm areas of ocean are. Now, as far as cold areas of ocean, that is a bit more of a problem. That takes away storm systems. So oceans are critical generators of weather systems, and since the ocean conditions change very slowly, they don't change rapidly at all, they're a very good basis, a good firm foundation for seasonal weather prediction. So based on these conditions, it's a very good place to start for sure. Now, that is quite true from late fall through early spring, season we're just coming into and will be out of soon. In our part of the world, it's really tied into ocean conditions this time of the year. So with that, let's break down what's been happening. Now, the sea surface temperatures remain colder than average in the box I just illustrated for you. That's the equatorial Pacific waters, and that's what creates La Niña conditions to be colder in that box region. Cold water means that area is absent from storm development. And over such a large area, the entire globe, its weather pattern will be affected by lack of storms there. It'll compensate by sending storms elsewhere. And the opposite true if that were El Nino. It'd be warm there and generating lots of storms. Now we're beginning to see some changes in one section of La Nina, and that's close to South America. Sadly, that region of El Nino and La Nina, which is called the 1.2 region, to be technical, it doesn't have a huge impact on Canada. It does have a bigger impact on trade partnerships with Mexico, the US. third box that's drawn now, that does have a bigger impact for Canada, especially this past cold season. That's colder than normal water that remains in the Gulf of Alaska. Let me explain why that's so critical for us across Canada and the northern US too. For North America, a very basic storm pattern is drawn now using that arrow. The warm ocean water in the central Pacific, as we discussed, it creates storminess, creates thunderstorms. Eventually, those storms become a storm system. However, as the storms pass over the Gulf of Alaska, it takes away some of the moisture. It's not warm, it's a cold area. So it robs the storm systems of some of that valuable water. So yes, we do have a storm flow that has moved over Canada and then into the central and eastern US, but because the Gulf is so much colder, it's really robbed us of a lot of that valuable moisture. La Nina does a lot of things, not just here across in North America or South America. It's a global impact. So I'll use a satellite product, and that's what you see there. It detects the health of vegetation. Greens are very healthy plants. However, areas have poor plant health as a result of La Nina and some of the associated storm tracks. The U.S. has drought-related issues across the southern tier, stretching into North Mexico, and it's all starting from the Central Plains. Much of Brazil has favored from a wet pattern, but southern Brazil to northern Argentina in a drought with highly stressed plants. Southern Mediterranean started the season off poorly, but has since improved. Healthy vegetation for the most part across India and Southeast Asia. And then we get into Australia, and wetness has favored eastern parts of Australia and North Australia, where vegetation is much healthier than last year. And that's really true in the sugarcane production areas, which helps molasses for feed suppliers. Now, I want to zoom into three particular areas of interest. We'll start off with South America. And why I did this is because remember the headlines from not long ago about corn concerns because of the weather in Brazil? Well, the past season, northern Brazil has had water, green shades, blue shades there on the map. Southern Brazil into northern Argentina really have not, and that impacted the first crop. Now, the second area of crop didn't benefit either. Very dry the last 30 to 60 days. So as you look at the health of the plants across Brazil now, those areas without precipitation circled there, notice the health issues in southern Brazil to northern Argentina. Those red shades indicate plant health in the lowest 10% of years since 1982. So these products try to visualize the current health of plants compared to every year, every season going back 40 years. So to be in the lower 10% implies you're in the top 5 of worst plant health, or top 5 of worst crop conditions. Now the outlook through June shows more dryness than moisture. That would be a good indicator for La Nina to continue. If Bahia here in Brazil were wetter, we'd actually have a better indication of El Nino kicking in for next year. Let me quickly talk about Australia because of the sugarcane and molasses impact. Past season moisture deficits across the north have been pretty substantial. They're only getting half or so of their allotted water. But then you look right in here, the sliver over the east, that's 200% in normal precipitation. And that does extend into the sugarcane areas. So that has helped the sugarcane crop, and the health for most sugarcane areas has really been quite good this year compared to last year and the year before. We've seen things drying off recently, and that does continue. Drier conditions across most of Australia, with the exception of the east, close to those sugarcane areas. That's normal. As they go through their fall and into their winter, things start to dry out. But La Nina for next year would also be a positive for the sugarcane crop and molasses products for next year, should La Nina return. Into the U.S. now, we have big problems down here. On the left, you have the past season with moisture extremes. We've had some extremes across the Northwest with some water. The Ohio, Tennessee valleys, missing most of the Corn Belt, has had some water, but the drought across California, most of those hay and alfalfa areas are pretty bad. Texas is also quite bad. Now on the right, you see the current snapshot of plant health across the U.S., south and southwest, and parts of New Mexico, pretty bad. And the drought across the region continues to negatively impact all growing conditions into the start of our spring here. We're looking at vegetative conditions in the bottom half, so lowest half of the past 40 years. And that happens with back-to-back La Nina years across the U.S. This will be an impact on the American Corn Belt this growing season, drought for much of it. as well as hay and alfalfa growers. Yet again, another year where things are going to be poor for most of those producers, I'm afraid. Let's shift our focus back to Canada, and we'll do so for the rest of the presentation, including the outlook. During the past 90 days, we have had some snowfall. Not what you would classically think of with La Niñas across Canada as being great snow producers. I'll talk more on that connection here in just a moment. The moisture has favored northern British Columbia, from Edmonton northward, Saskatchewan, Manitoba, some areas of wetness, and the Maritimes too. Ontario and Quebec have been quite hit and miss for moisture in the northern areas, and a little bit closer to normal, to slightly above coming in the southern sections there. In terms of the early growing season, I know it's super early to be talking about plants getting green and things, but it is early. But the satellite measurements through the last few days have relatively normal start to the vegetation there. And that's despite ongoing drought. I need to talk more about that now. So I'm going to zoom into the prairies, kind of the drought focal point across Canada. That distinct line between the wetness, you see the green areas kind of cutting everything central and north, and the drier areas across the south. So Fort St. John to Edmonton, Saskatoon, Winnipeg, found some moisture there, and certainly to the north of that line, if you will. You can see where most of the storms tracked, kind of falling right along that dividing line, if you will. That's where the storms were. That's kind of common for La Nina years. However, La Nina used to carry a lot more water with it, the storms across the Pacific, but as I talked about, the Atlantic Ocean, the Gulf of Alaska, has robbed the storm systems a lot of that valuable moisture that would have gone into snow. So we also saw a transition in the Atlantic about 20 years ago, and that caused La Nina to behave differently in the past 20 years than you may commonly think of going back to the 50s, 60s, or 70s. It's behaving differently the last 20 years or so. So La Nina's impact certainly did hit us hard over the last 90 days, most of winter. So yes, there were some areas of recent moisture. That's a good snapshot of the soil moisture today here on the left. So soil moisture conditions may not be as bad as you might think. Forest soil conditions, though, are bad east and south of Calgary. The wettest conditions are noted in the deeper greens here, those areas that did get at least some snowfall and did end the winter season slightly above average as far as preset. With that said, though, an okay with moisture in soils, that's just for the winter. That's a very short duration. I just put on another map. This is long-term drought. So we're not talking about the short-term snapshot of soil moisture. We're talking about the long-term snapshot of where we need water. The water deficits, that long-term situation is still bad. You do have some benefits here. Great Lakes shooting out toward the Maritimes. And some of the mountains are not doing too bad at all. They're in a surplus from long-term droughts perspective, but didn't get the recovery needed for much of the prairies, despite having some positive notes, some surplus of water throughout the course of the winter. Just wasn't enough to beat the long-term drought. It may have helped the short-term soil moisture, but that's it. So that's a brief state of conditions through today. That's what got us to today. How do things change in the forecast? Well, sea surface temperatures, as I discussed, they're the main weather driver, especially winter, and that driver decreases a bit into summer, but we discussed that weather pattern earlier. Now, the large image on the screen, that's sea surface temperature anomalies during March, warm and cold ocean. I've identified with black boxes the key areas of warmer and colder ocean conditions that will contribute to April through August forecasts for us. Sea surface temperatures won't change too much across the northern hemisphere until we get later into spring, summer, and see what La Nina or El Nino want to do next year. Now, we also have to worry about the atmosphere above. That's the small box here. I highlighted areas using the black boxes in the atmosphere, looking at waves, and they're roughly about 10,000 feet into the air. That's where most of our storm systems and moisture come from. And when I take those key areas boxed on the previous slide, I put them through a statistical process, and I test the strength of these current conditions to those of the years past. In front of us are two grids created from two analysis periods, one from February and then March is on the right. And I just completed that one a few days ago. The grids show statistical strength of past weather patterns to the current pattern. These two lists are meant to be an example for you, not necessarily ranked in any sort of way. So don't take 1950 to be a great year. I mean, it's in the top 20, but these are not ranked. Just an example for you to see my process. Now, when I create these tables, I reveal a number of very noteworthy years within the higher correlations. I may grab the best 10 or 20, and this year I did the best 20. And that goes back to 1950. I then analyze to see if they make sense for this year, meaning I'll go through these years one by one and see if the oceans and atmosphere evolved throughout the year similarly to how 2022 has gone through. I'll consider, is a particular year similar because of La Niña? Are the observations similar? Is El Niño expected? And I compare them in all such ways. And then I get very specific. I begin to consider similarities to droughts, snowpack, decadal climate changes. It's a lengthy analysis to weed out good years from the bad. A very small handful survives. Maybe just as few as 2 years may come out of this as good matches to build a forecast from. And I'd like to get 5 or 6. But again, 2 to 5 or so is a final cut. So with that said, let's go ahead and take the best fit years for April to June of 2022. This is combining what I feel like are the best fit years for the next 3 months. We have wetter versus drier conditions shown on the left for April through June. Drier conditions will be found farthest west, British Columbia. Areas of wet weather, the green and blue shades, more likely in southern Saskatchewan, stretching out over to Manitoba, Ontario, Quebec, near normal moisture areas where you don't see any color shading. On the right is a warmer versus colder conditions through June. Very strong cold signal appears from the prairies out to about the Great Lakes or so. Warmest conditions for those farthest east. Now, these cold temperatures you see right there in the middle of the country, they correspond to an area of unsettled weather that is generating the moisture around the Great Lakes. This unsettled area, we'll call it a trough. That's what it is, a trough. It may very well be a factor into the summer too, so I'll discuss that in just a moment. In full transparency, my analysis gives me about an 85% confidence in the forecast you see here. Dry west, wet periods for the prairies, wet periods around the Great Lakes, and cold across the central and east. That can help with the drought situation if we do get that moisture. Before we look farther into the future, let's take a closer look at month by month. Our best chances for moisture will come in May. You see the greens and the blue shades here in April versus what happens in May. May, based on the history, we improve things quite a lot, get much more moisture coming through. The exception will be the far west coast. But again, out of the next, say, 2 to 3 months, May and also into June may be the best chances for some water. Now to summer. Let's go June through August. We have the history-based projections for the summer shown now. It's on the left and also the right are temperatures. The dry areas do continue for British Columbia. Prairies likely remain largely drier than average in the drought zones. Drought feeds drought. It's a cycle. It takes a lot to get over a drought, so plan on more drought conditions there. Water likely to the north, where it has been throughout the course of the winter. And as far as temperatures, drought feeds warmer temperatures, so it will be warmer in the southern prairies in British Columbia. I'm most cautious about that dryness, though, we see in Ontario and Quebec to the Maritimes, indicated here. Looks quite dry. I think the analog years, the best fit years, are too dry. I think these areas will actually favor from a bit more moisture than what you see here, and they'll also have colder temperatures versus what you see here. It's part of that trough we talked about in the central part of the country. I don't think it dies and goes away. I think it does linger into summer to bring some of those changes. But again, you have summer based on left and right images here. Probably not the best news for the drought area. All analogs point to more drought there, stretching into the northern U.S. drought areas as well, including northern South Dakota, where my family farm is. So it's not the best situation for getting water. And with drought conditions there, we really will likely see very warm temperatures as well. Now, if you look month to month, June, July, and August are displayed now. June is most favored by a little, unless you're, say, in Ontario and Quebec. All 3 months are likely to be dry if the current analog forecast, the best fit years, continue to pan out. I hope my hunch works out so we can get a little bit more water in there and some cooler conditions. So again, in full transparency here, if I judge my summer forecast or those best fit years forecast, I give it about a 70% confidence. In what we have over the next couple of months is several more analyses. After each month, I redo all of these years, create a new list. And from that list, we may begin to see a wetter period off to the east or even for the prairies. But right now, we do not have that. Until we get into April and see what April has done in total, my confidence for the summer stays at 70%. That's still quite high for a summer forecast. I do want to talk about next fall into winter. What's likely to happen, La Nina or El Nino? And I'll end on this note. As we look at this chart, this blends several models together. It shows the combined model probabilities of being in La Nina or El Nino. So the timeline, here we are, March, April, May, or even April, May, and July. The blue bars, the tallest, that's La Nina. We know we have La Nina, we're in it now. As we look at July, August, September, October, September, October, all the way to the far right, that's November, December, January. We are likely leaning to either neutral or La Nina conditions, even in the model projections. And that right red bar there, that's El Nino. It's not out of the question. However, it is not necessarily likely to happen to get us into El Nino. So I know this presentation has been brief. You contact me. I'm here to help you plan on the future. If I didn't understand, you need to see the graphics more closely. Want me to walk through them again? Ask. That is my job, is to help effectively communicate these weather situations to you so you can best prepare for the future. I look forward to your questions either here or in the future, and hopefully I get to meet in person with you all very soon. Sadly, for the drought areas, I wish I had better news, but let's plan for the worst and hope for the best.